Good morning. We will continue our discussion about the force on a current carrying conductors. In the last session, we learned that when a current carrying conductor is placed in a magnetic field, it experiences a force, and the force is given by F is BIL sin theta. That is the magnitude of the force. Now, in case if we have two conductors which are placed parallel to each other and both the conductors carry some current, is there any force between these two conductors? Because we know that a current carrying conductor produces a magnetic field. So the magnetic field produced by one conductor, is there any effect the magnetic field produced by one conductor on the other? Now first we will take down a question, then we will derive that force equation. A steady current I1 flows through a long straight wire another wire carrying steady current I2 in the same direction is kept in the same direction is kept close and parallel to the first wire. Show with the help of a diagram how the magnetic field due to current I1 exert a magnetic force on the second wire. Deduce the expression for this force. Okay, now let us read this. A steady current should be C. A steady current I1 flows through a long straight wire. Another wire carrying steady current I2 in the same direction is kept close and parallel to the first wire. Show with the help of a diagram how the magnetic field due to current I1 exerts a magnetic force on the second wire. Deduce the expression for this force. So here we are given with two wires which are placed parallel to each other and close to each other. Now the current in one wire is I1, the current in the other wire is I2. Let us say we are placing two current carrying conductors parallel to each other and close to each other. Let us say the current in this first wire is I1 and the current in the second wire is I2. I will mark this as wire number 1, wire number 2, or you can take it as first wire and second wire, anything will be fine. First wire, second wire, and let us say the separation between them is equal to some distance r, some length r. Now we can write these things. Let two infinite long straight wire carrying currents I1 and I2 currents I1 and I2 are placed as shown in the figure. Let R is the separation between the wires or conductors. Now we know any current carrying conductor produces a magnetic field around it. Therefore, the current I1 in this first wire will produce a magnetic field. I can say that I2 flows in the presence of a magnetic field which is produced by I1. Because any current carrying conductor produces a magnetic field. Current I1 produces magnetic field around it. So current I1 produces magnetic field around it. Therefore, the field produced by I1 on I2 is given by, so magnetic field B1 due to first wire on second, due to first wire is B1 is equal to, we know for a long straight wire, you know, the magnetic field at a distance r is given by mu naught by 4 pi is mu naught divided by 4 pi into 2I1 by r. Now to obtain the direction you have to apply the right hand grip rule. So hold the conductor I1 in your right hand such that your thumb points in the direction of I1. The other curled fingers will give you the direction of the field. If you apply that, the field due to I1 at any point on I2 will be, the direction will be perpendicular to the plane of the paper and inward. So at any point, you know, so it will be like this near I2. This is, you know, this cross is the field B1 produced by I1, that is cross. So due to this magnetic field, I2 carrying conductor will experience a force. We can write the direction here. So I will write B1 as mu naught by 4 pi. The current is 2I1 divided by r, and the direction will be perpendicular to the plane of the paper and directed inward. That's why cross. So at any point, so here this is B1, the field B1. B1. Now I can say that the current carrying conductor I2 is placed in magnetic field B1. Therefore, magnetic force on L length of the wire 2 is given by, let us assume some L length of the wire, because it is infinitely long wire. I'll take this much length as L. L is the length, okay. So we can say the magnetic force on L length of the wire 2, on wire 2. Magnetic force on L length of the wire 2 is given by F2 equal to I2, it is BIL, so current in the wire 2 into the magnetic field in which it is placed into length of the wire, and the angle theta. So here it is perpendicular, L and I are the length and the magnetic field are perpendicular to each other, so that is why the angle is 90 degree. Now substitute for B1. We have B1 as mu naught by 4 pi mu naught by 4 pi into 2 I1 by R into L. Sin 90 is 1. Or I can write force per length F2 by L is equal to mu naught by 4 pi into 2 I1 I2 by R. This is the force due to current I1 on the conductor carrying current I2. Mu naught by 4 pi into 2 I1 by I2. So this is force per unit length. This will give you the value of force per unit length. Force per unit length. Force per length. Mu naught by 4 pi into 2 I1 I2 by R. Now the direction of this force is obtained by Fleming's left hand rule. So the direction of the force is obtained by Fleming's left hand rule. So the direction, if you find out, it will be perpendicular to the second wire in the plane of the paper towards the first wire. The direction is perpendicular to the wire 2 second wire, perpendicular to the second wire in the plane of the paper towards the first wire. Towards the first wire. So now the direction you can show in the picture as F2. This is the direction of F2. F2. So deduce the expression for this force, how the magnetic field due to current I1 exert a magnetic force on the second wire. This is the force on the second wire due to current in the first wire. Next we will see in the coming class we will see like how the current in the second wire exerts a magnetic field or produces a magnetic field, and due to this magnetic field how a force is experienced by the conductor 1. Okay, so for this deduce the expression for this force, that is magnetic field due to current I1 exert a magnetic force on the second wire. So this force is given by force per length is F2 by L is mu naught by 4 pi into 2 I1 I2 by R.